welcome all to the webinar, and Birte, the floor is yours. We are very, very happy for you to joining us today.
Yeah, and thank you for the introduction to Dorota and Dilan, and also the invitation. And in this talk, I focus on the role of language in mathematics education, and I will give you a talk about my PhD thesis, which I finished in 2017, and it has a title you see here: Conceptual and Lexical Learning Trajectories and Learning Pathways for Percentages. Before I start with presenting my PhD project and my PhD thesis, I would like to give you a short overview of my academic background. From 2013 to 2017, I was a PhD student at the Institute for Development and Research in Mathematics Education at TU Dortmund University in the team of Susan Prediger. After my PhD disputation in October 2017, I work as a postdoc in the team of Susan Prediger. And since October 2019, I'm an assistant professor at the University of Cologne for mathematics education, but with a focus on students with special needs. Yes. We'll go further, and I would like to start with my talk. And first of all, I will show you the structure of my PhD thesis and also the focus of our webinar. My PhD study consists of three research elements: condition research study towards percentages, a design research study on percentages, which is the core of our talk today, but also of my PhD thesis. And I also conduct effectiveness research for percentages and for the learning arrangement I developed. The core is the design research study, which is also the focus of this talk. And nonetheless, at the end of my talk, I will also outline the key findings of the other two framing studies, because I think they could be also of your interest. Within this talk, I will first shortly present the theoretical background. This theoretical background, which is relevant for the design research study. And I will formulate the design requirements, the research questions, and will shortly present the methodological framework of my study. And then I will present you the central design results as well as the research results will be presented in more detail. And as I said, at the end of the talk, I will briefly show the central results of the other two research elements, the condition and the effectiveness research on percentages. And after that, I will formulate a short conclusion. And now it is your turn, and I invite you to reflect about and answer the following question. What difficulties do students, in your opinion, especially students with low language proficiency, typically have with percentages? Because this was the starting point of my PhD thesis, and for that I have created a Mentimeter poll. And you can go to www.menti.com, and there you have to fill this code you see here. And then you have, I think 3 minutes are enough to think and write down what difficulties, in your opinion, students have with percentages in school. Difficulties, I have brought a typical example from my work, my PhD thesis. And here we see a typical difficulty of students that they mix up the amount and the base. And you also say it's difficult for students to identify the concepts. And here we see in the task, Mrs. Fuchs has prepaid 40% of the price for her holiday trip. This was 800 euro. How expensive is the trip? That one student mixed up and said that 800 euro is the base and not the amount. And another student said explicitly that he doesn't know if 800 is the base or the amount. And we see that this is one problem also, which is also said in the literature. So this brings us to the theoretical background of the topic. And from the perspective of mathematics education, we have an ambivalent situation regarding these topics. And this can also be illustrated by research results. And this forms the theoretical starting point of my work. So on the one hand, percentages are omnipresent in everyday life. And we can say that these are one of the central learning contents in mathematics education. And this can be seen, for example, in a comment also from a student, who have to solve the problem. There is a 20% discount on a t-shirt. The t-shirt costed 30 euro before. How much does the t-shirt cost now? And the student solved this problem correctly and said was very easy, this person problem, because I also often calculate such things in my head when I go shopping. But on the other hand, and you collect many difficulties, on the other hand, the topic seems to evoke difficulties of students to a particular extent, especially after having dealt with percentages in class. After percentages are taught in class, many students show difficulties with this topic. And Zill, a German mathematics educator, said that developing a conceptual understanding of percentages as well as skills in solving simple person problems appears to be one of the greatest deficits in mathematics general education in our society. And for me, this was a legitimation to examine the content area of percentages from the perspective of mathematics education in my PhD thesis. And there are central reasons for typical students' difficulties with percentages. And Parker and Leinhardt identify two central complexes from reasons for students' difficulties. And on the one hand, as the quotation from Zill makes clear, we have a lack of or an incomplete conceptual understanding of percentages, and this could be responsible for the problems the students have. And this arises, this lack of conceptual understanding, from the variety and the complexity of the mathematical content. You also said that there are different and contents, and also that in school we have a heavy instructional emphasis on person procedures and not on the understanding. And also there is often, and you also said this, that we have an overemphasis on few relations, especially on the relation or the concept part of a whole. And on the other hand, the language of percentages is comparative and it is very concise. We have implicit relationships that underlie percent and its referent quantities. And this comparative language enables a variety of formulations in percent problems. Due to this, the role of language for percentages I briefly sketched here suggests that taking an additional perspective of language education for this topic is worthwhile. And so we have the role of language in mathematics education also in this perspective. And now I will have a little look also on theoretical background for the perspective of language education. In general, and if you also have this this topic in your PhD, this is very clear for you, but it was very important for me in the start of my PhD thesis. Language in general is considered to play a significant role in learning mathematics, and this applies to a dual function of language. On the one hand, we have the communicative role. So language is a medium of knowledge transfer. And on the other hand, we have its epistemic role as a medium of thinking. And this role is very important for mathematics learning. The relationships between language proficiency and mathematics achievement is also demonstrated by several and various international and national studies. Thereby we see that also and especially the competencies related to the register of school academic language proving to be particularly relevant. And this gives rise to the requirement that we have to integrate academic language demands and competencies in mathematics learning in school. And the characteristics of the academic language is the language is context reduced, incorporate complex linguistic means, and is conceptually written. And to implement this requirement in the sense of linking the two perspectives, the perspective of mathematics education and the perspective of language education, the design and research of learning arrangements which are language and mathematics integrated is advocated. And so it is also a requirement to explicitly address the academic school register in school and also in this learning arrangement. Due to the fact that we have a gap in design and research, in terms of percentages, the overall aim of my PhD study was to develop, try out, and research such a learning arrangement on percentages, which is mathematics integrated and language integrated, and to design a learning arrangement towards percentages with concrete tasks. And the consequence, the desirable consequence is that this will reduce students' difficulties with percentages, and especially the difficulties with for students with low language proficiency. And to achieve this goal or this aim, it is relevant to consider both perspectives and the theoretical background from both perspectives. On the one hand, the perspective of mathematics education, and we need to specify and structure the content. And on the other hand, the perspective of language education, and we also have to specify and structuring the content from this perspective. For this, to structure the content, I used in my PhD thesis the construct of intended learning trajectories. And these represent planned structuring in the form of idealized offers of learning opportunities. So I have activities, a task, and also learning aids. And these learning aids are scaffold elements, which I will present later. And the construct of intended learning trajectories is based on the assumption that the intended learning trajectories can trigger multiple and oscillated learning processes. And so I say, or I conceptualize these learning processes as individual learning pathways. Intended learning trajectories are designed by integrating, connecting, and sequencing the aspects identified as relevant in the context of specifying the learning content. In my case, the learning content of language and the learning content of percentages. Within my PhD, I try to link both the perspective of mathematics education as well as the perspective of language education. And so I realized it by design intended dual learning trajectory. And so on the one hand, it consists of a conceptual learning trajectory for learning mathematics and in a lexical learning trajectory for learning the language for the topic of percentages. The sequencing basis of the conceptual learning trajectory is the level principle from the RME approach, the realistic mathematics education approach. And according to this principle, learning trajectories should start with realistic context problems as starting points of learning processes. And I will show how I realize this for the percentages. And from these realistic context problems on, they progress successively from the concrete context problems to the abstract learning of mathematics. And following Gravemeyer, we can distinguish 4 levels. And these levels relates to the increasing deepness of understanding for mathematical concepts. And he distinguished the situational level, the referential level, the general level, and at least the formal level. And I will show you these levels later for my concrete learning trajectory on percentages. On the other hand, we have the lexical learning trajectory. And for this, I use to sequence it by the design principle of macro scaffolding. And the idea of macro scaffolding is to sequence the intended lexical learning trajectories from everyday language, from the students' everyday resources via the academic school register towards the technical register, the formal vocabulary, for percentages, the base, amount, and rate. And due to the specifics of mathematics education and the mathematics as science, the principle requires concretization, and this is provided by the model below, which focuses on developing meanings for mathematical concepts and relations, in my case for percentages. And following this model, which was developed by Susan Prediger, the lexical learning trajectories are to be sequenced over 4 levels, which start with the students' everyday language resources. Subsequently, meaning-related vocabulary is to be established. For example, for percentages, things like new price or something like that. A new price for the amount, or old price for the base. And then the formal vocabulary, the lexical means like rate, base, and amount is to be introduced. And finally, the 4th level is based on fostering the use of extended reading vocabulary, which students are confronted with, for example, in exams or person problems or newspaper articles. And I think this would be clearer when I will present you my trajectory for percentages. Consequently, based on the theoretical background, for my PhD thesis, 4 global requirements have to be met when designing a language and mathematics integrated intervention on percentages. And these refer to the concrete design of the 2 learning trajectories, the conceptual learning trajectory on percentages on the one hand, and the intended lexical learning trajectory on percentages on the other hand. The 3rd design requirements based on the intertwinement of both intended learning trajectories. In my case, I use a graphical representation, the percent bar, and we have to design a learning arrangement for realizing the dual learning trajectory on percentages with concrete tasks, for example. The associated research interest is then to investigate the situational effects of the developed intended dual learning arrangement. And within my PhD thesis, this is done by means of the following 4 research questions. But within this talk, and with a focus on the role of language, I focus only on the investigation of lexical learning pathways by research question 3. And research question C is which students' learning pathways can be reconstructed along the intended conceptual and intended learning, lexical learning trajectory. In order to be able to meet the realization of the design requirements and also the research interesting, I use the research program of didactical design research in the Funken model, which is established in at the TU Dortmund University. And I use this as a methodological framework. And I will only shortly present the relevant aspects of this framework. The methodological framework consists of 4 working areas. The 2 upper ones relate to design activities, relating to the design activities, and the lower ones to the research activities. So in the first round, we specify and structure the learning goals and contents and develop the design. And later on, it goes to conduct and analyze design experiments and to develop local theories on the teaching learning processes for the content, in my case, for the content of percentages. And one characteristic of this methodological framework is that the working areas are iterated through in cycles. And finally, we could generate, on the one hand, design results, and on the other hand, research results. And I would present to you my design results and also my research results later on. Within my design research study on percentages, I conduct a total of 5 design research cycles. The cycles 1, 2, 3, and 5 were situated in small groups of 1 to 3 students. And I also conduct one cycle, the 4th cycle, in a whole class setting. And as part of the design process or the development process, the cycles serve to successively optimize the design of the dual learning trajectory on percentages. And later on, we will have a look in the 4th cycle. And now we have a little break, and and you have time for ask questions, and I think we can use the chat for this. My central design results of my PhD thesis, and later on the central research results. So one of my central design results is to design the conceptual and the lexical learning trajectory on percentages. And for the conceptual learning trajectory, it was possible to draw on an established trajectory, conceptual learning trajectory on percentages from the realistic mathematics education approach. And my task was to adapt this to the German context. With regard to the lexical learning trajectory, there was a research gap. So there I have to do more design work, and and more creativity was necessary. For connect the conceptual learning trajectory and the lexical learning trajectory, I use the person bar as a structural link. The person bar was used to coordinate these two learning trajectories. And the person bar as graphical representation, you see, if you don't know a person bar, you see it here, was used, it meets general topic independent as well as specific quality criteria. So topic independent for graphical representations, and also specific quality criteria for graphical representations for the topic of percentages. And according to some design principles I integrate and found in the literature, it is relevant that we have a consistent graphical representation, and the person bar meets this demand because because the person bar could change its functions, and I will show this to you later on. The intended dual learning trajectory, you see, it is very complex, but I try to take you with me, and you don't have to read all the things we see here. The intended dual learning trajectory on percentages, which was conceived on the basis of the theoretical considerations, derived design principles, and also empirical findings from the first cycles, consists of 6 levels. that are concretized with regard to the conceptual and to the lexical learning trajectory. And the first 4 levels are the levels you also see in the models before. And the 6 levels progress from the activation of individual resources for the topic of percentages, but also for the vocabulary on percentages. And it goes further to the flexible use of concepts and strategies on percentages. And the formalization, the person formulas, the calculating of amounts, rates, and later bases are in the 3rd level. And at the levels 4 to 6, we have an expansion to include also extended problem types. That means beyond finding the base, the amount, and the rate. And we also have here extension of the vocabulary and a focus on dealing with person problems, and a focus on this, what you said is very difficult, to identify the concepts in different, in a variety of person problems, because this is very difficult for students, especially with low language proficiency. And the person bar functions as a structure-based scaffolding in these 6 levels, and with changing functions and also with changing presentations. And the idea is that it helps to initiate and also to support the learners, the students progress along the learning trajectories. And this is noted in this table, but you don't have to read this too. But I will say that in the beginning, we use the person bar as a model of a familiar context, the download bar. Later on, we have the person bar as a model of situations in the shopping context. And later on in the level 3, the person bar is a model for calculating percentages. And later on, it is a model for constructing more complex relations to this. And here you see that the 6 levels of the intent dual learning trajectory are concretized by tasks. This is these are the elements of the learning arrangement, and the tasks have different conceptual requirements, functions, and presentations of the person bar, and also different lexical means for the concepts related to percentages. We have here already gigabyte downloaded, new price, then the formal vocabulary like amount, and so on. And now I would like to present you a task example. And there you see that also the communication about the concepts are very relevant for this learning arrangement. So this is the 3rd task of the learning arrangement. And in this task, which is situated in the download context, the students have to estimate and determine a rate of a download bar, and also the amount, how much gigabytes the film has already downloaded, but they have to estimate this. And for doing this, they can use flexible and informal strategies. So many of the students go to the half of the amount and say 50% are 6 gigabytes, and then they go further to determine the rate and the amount here. And we see here that they have to explain your ideas, and this is very important in terms of language learning. The learning arrangement on percentages that I developed consists of a task sequence of 21 tasks, and these tasks have been summarized into 3 units, ABC. And in addition, I have or the learning arrangement includes micro-scaffolding strategies that serve to adaptively support students' progression along the dual learning trajectories. Yes, and now if you have questions to the central design results, feel free to ask something. I will progress to present the central research result of my PhD thesis in terms of the lexical learning pathways. For this purpose, for this purpose, and in order to address the research question 3, which students' learning pathways can be reconstructed along the intended lexical learning trajectory, I invented the method of trace analysis, and it serves to capture students' lexical learning pathways in a longer term perspective. It also serves to systematic analysis of situational effects of the learning arrangements on students' lexical learning pathways. And the analysis procedure finally consists of the 3 following steps. The steps of the trace analysis you see here, and you also see the categories I use for this. In the first step, all lexical means for expressing concepts relevant for understanding percentages, such as base, amount, and so on, are inventorized, and they are identified both in the offered lexical means. The offered lexical means are the written material and also the teacher, and in the lexical means used by the students. And subsequently, I categorized the lexical means to their types. And here I made a distinction between lexical means that are related to the person bar, a structural scaffold, to the several contexts, the context of the download bar, the familiar shopping context, and less familiar context. Also, lexical means which are context independent, like 100% or something like that, and the formal vocabulary like amount, base, or rate. The second step was to identify the sources of the activated lexical means. Thus, I determined whether the students have introduced the lexical means, like new price or something like that, themselves, or whether they have adopted it from the other students, the teacher, or the written material. And this, in the third step, I look for the initiative of each lexical mean. That means if the in the situation the students initiated the lexical mean themselves, or the teacher with a micro-scaffolding move initiate their use of the lexical mean, or in some cases also other students of the student pairs. The trace analysis I conduct, as I already said, in the fourth cycle, and I conduct the trace analysis for 6 students, which were in grade 8 in Germany. So you can say they are 15 years old, and they were supported in 3 pairs. And the pairs are from students with different language backgrounds. So we have Amir and Sarah, which are one Amir have low language proficiency and Sarah high language proficiency. For this, I had a C test. And we have Gizem and Melek, both with low language proficiency, and Julian and Victor, both with high language proficiency. And for this, I coded in the process, a total of nearly 3,000 lexical means users were coded. And in order to be able to make comparisons with regard to the lexical learning pathways, for example, across the levels, but also between the learners and the pairs of learners, I make quantifications on the basis of the 3 categories, the types of lexical means, the sources, and the initiatives of lexical means. And based on these, initial hypotheses were first derived from the first case, from Amir and Sarah. And these were differentiated by comparisons with the trace analysis of the other 2 pairs, Gizem and Melek, and Julian and Victor. And the differentiated hypothesis then formed the basis for initial interpretation of the effects of my learning arrangement. And these interpretations I will present you now for the 3 categories. With regard to the types of activated lexical means, we see mainly an agreement or a parallelity between the intended lexical learning trajectory and the individual learning pathways. And this indicates that the learning arrangement supports the progression of the individual learning pathways along the lexical learning trajectory. The trace analysis reveal too that the context-related lexical means from the familiar shopping context, like new price, old price, and so on, are also taken up at later levels of the intended dual learning trajectory. And this indicates that these lexical means are very relevant for the construction of meanings for percentages for students. Therefore, and also for the communication about the percent concepts, the percent bar also seems to be of a high importance for students. Also especially for the students with low language proficiency. And this is also shown by the fact that the students use percent bar related lexical means almost at all levels. For the sources of activated lexical means, we see the trace analysis show that adoptions from the collective vocabulary predominate over self-inventions. So the students introduce not so many lexical means themselves, but they adopt them from the written vocabulary and also from the offers from their teachers. This illustrates the importance of lexical scaffolding, the moves, the micro-scaffolding moves for individual lexical learning pathways. And we also see that the adoptions from the written material predominate over those from oral authors. In my case, we have other studies where this is not like this. And the students adopt lexical means rather from the repertoire of the teacher than from the repertoire of the other students. Across the 6 levels of the intended lexical learning trajectory, we see that the self-inventions tend to decrease. And you see this in the diagram on the sources of AMIR's activated lexical means at each level. And this is consistent with the sequencing of the intended lexical learning trajectory, which first aims at activating students' resources in everyday register, and later on intends to establish certain types of lexical means from the shopping context. The analysis of the initiation of activated lexical means leads to the conclusion that the use of lexical means is mostly self-initiated and less often teacher-initiated and hardly initiated by other students. Thus, we can say that the learning arrangement seems to stimulate the language production of the students, but often we need microscaffolding moves by the teachers for activate this. This seems to be especially true for the establishment of lexical means at later levels, because the self-initiated use of lexical means decrease over the intended learning trajectory. In the level 3, the formal vocabulary, we need a strong, or we need the teachers who say you have to use vocabulary like rate, amount, or something like that. And this you can also see, for example, in Sarah's initiatives for activated lexical means at each level. Yes, we have another time for questions in the case of for the central research results presented here. Yeah, perfect. As initially outlined, further design and research results were generated as part of my PhD thesis. And on the one hand, these can be traced back to a condition analysis carried out on typical linguistic students' challenges in dealing with percentages. And it was before starting the design research on percentages. And as part of this research, I designed a percent test that contains systematically varied problem types, find the base, find the amount, and find base after reduction, and problem formats. You see here a pure format, something like 25% off €100, the visual format with a percent bar, and percent problems in text format. And the implementation of this test shows that students with high language proficiency perform higher in all items than the students with lower language proficiency. And interesting was that the results of the two subsamples are mostly parallel with respect to the different problem types and formats. And thereby, and this was very interesting, the advantage of the students with high language proficiency is greater with respect to the pure format than to the text format. And this result is the most significant research result of this part of my PhD thesis, which is the topic-specific contradiction of the commonly held assumption that exclusively students' restricted reading proficiency is responsible for difficulties in tests, but we see that the conceptual understanding of percentages is very, very important for the students with low language proficiency. And this was one of the reasons that within the design research, I focus on fostering the conceptual understanding of students. In addition, I conducted a quasi-experiment in classroom setting with a pre-post design. And this was part of the effectiveness research. And I will show you the central results here. We have the result that the intervention group, which was taught in a whole class setting with my learning arrangement, achieved better frequencies of correct mathematization in the complete person test, and among other things, also with regard to the word problems in text format, then the control group. And the control group has participated in a conventional instruction on percentages. And then, accordingly, the most significant research result of this research was that we have a first quantitative proof of the effectiveness of the designed learning arrangement. And we have another PhD thesis in the group from Susan Prediger who make this with a bigger sample and also find evidence of the effectiveness of this learning arrangement. And so I come to the conclusion. We see that I have three elements of research: the condition research with insights into typical student challenges with percentages obtained on the basis of a developed person test. We have the focus on the design research on percentages, and there we have a conceptualization, a theoretical conceptualization, and also a topic-specific concretization of the construct of the intended dual learning trajectory. We have the concrete language and mathematics integrated learning arrangement on percentages. And we see in this talk the individual lexical learning pathways in a longer term perspective with the invented method of trace analysis. And we see at least that we have, in my PhD thesis, first insights into the effectiveness of this learning arrangement in a whole class setting. And this generates many implications on different levels and also potential for further studies for this topic of percentages, but also for the topic of the role of language in mathematics education. And so we have some minutes for a discussion or for further questions.